Good morning. Today we are going to cover section 2.5, piecewise defined functions. Be sure to write down your title, copy your essential question. How do you use piecewise functions to model word problems? Place your cutout, glue it or copy it down, and then we have example number one. Go ahead and pause it and we'll continue once you're ready. So a piecewise defined function is defined by two or more equations over a specific domain, where we have f of x is 2x plus 1 when x is less than 3, and negative 3x when x is greater or equal to 3. And you guys covered this past year in Algebra 2. You covered this piecewise function. This is your domain, so this equation applies only when x is less than 3, and this equation will apply when x is greater or equal to 3. To graph a piecewise function, graph each equation separately over the specific domain. So let's go through example number one first. Go ahead and pause, copy it down. We're going to create a 5 by 5 graph. So in this case, 2, 4, 5, 2, 4, 5. We'll be doing the same thing here. So take the time to graph the first equation and to graph the second equation and see what you get. And we'll go and pause it and we'll start once you're ready. Excellent. So in this case, to graph the first function, this is a linear function, so this is a y-intercept, -1. My slope is up 3 to the right 1, or the opposite. Or domain. For this function is, we can plug in any values of x. Remember, they want to think about two ways. Algebraically is what values can I plug in for x? There are no restrictions. I can plug in negative, 0, positive. So therefore it will be all real numbers. So from negative infinity to positive infinity. And for your range is what values do you get back? So notice that in this case you can see it by your graph. You get negative numbers all the way to positive numbers, so all real numbers. For letter B, we have an absolute value. Your vertex is 2 and -3. I'm going to place my line of symmetry, and those are the ones that we cover back in the last section. This is an absolute value of a line, so therefore my a value is 1. I'm going to use that as my slope, up 1 to the right 1, and I'm going to reflect it. I need to find my domain range. So my domain, what values can I plug in for x? I can plug in any number. So I get a graph if I plug in -5, 0, all the way to positive infinity. And my range, what values do I get back for y? So we get back values for y starting at -3 all the way to positive infinity. And remember that in this case, positive 3 is included, so we're going to place a bracket. And that will take us to example number 2. So example number 2, we have a piecewise function. Take the time to copy it down and we'll start once you're ready. Go ahead and pause it. So in this case, we're going to make a 5 by 5. I'm just going to place it at the center. 2, 4, 5, 2, 4, 5. And if you notice, this piecewise function is made up by two equations, two functions. And the first one is 3x minus 1, which is the one that we graphed above. The second one is absolute value of x minus 2 minus 3, which is the one that we graphed here. And this is your domain for each part. So therefore, the first one, 3x minus 1, will only apply when the value of x is less than or equal to 1. So I'll add 1. All the values that are less are to the left, so that will apply to that part. And if we go back over to this graph, that's going to be the only part that we are going to take. So it might be useful, just like you guys did last year, I'm going to place a dash line with a pencil. And I'm going to do the same thing here. And I'm going to copy this part of the graph is the one that will be copied down here. So let's do that first. So let's see, my y-intercept suppose 1. My slope is up 3 over 1. Notice that I still include that point. So I do reach that dash line over. And I'm going to make my graph. I'm only copying that part of the graph. In this case, 1 is part of the solution for this graph, so therefore it's equal, so it's going to be a solid point. Now let's continue to this part. This graph, the absolute value is going to be applied only when x is greater or equal to 1, which is this part of the graph. So I'll be doing the same thing. I'm going to make my dashed line here. So that is the part that we are going to copy, and only this part of the graph will be copied, that part of the graph. So therefore, I'm going to just copy down my vertex was 2 and negative 3. And then from there, I can just quickly copy it down. In this case, your domain is x is greater. It doesn't include the 1 for this graph, so it's going to be an open circle. Same thing that you guys covered back when we cover inequalities, close and open, depending on whether it's an equal sign or not. My domain in my range. My domain, I do have a graph throughout, so it'll be all real numbers. In my range, I do also have a graph throughout, so it'll be all real numbers. Now we can also graph using a graphing calculator. So most of you guys should have a TI-84. You can also do it with Casio. You just have to look up the instructions online. Actually, I can also use a Casio in the classroom, but for this online video, I'll be just using my TI-84 to make it a little faster. So what I want to do, I want to go into y equals, and I need to type in a fraction bar. Let's see what I get less refraction. So therefore, I do want to be able to So I'm going to type in the first equation, and I just want this part of the graph. So therefore, try to get a better shot of my. So we'll do this. So in this case, I want to be able to type my first equation, but this is a piecewise function. Some of you calculators, if you go on the math, you might have a piecewise function in here if you have the latest operating system. Mine doesn't. So what I'm going to do instead, I'm going to have y equals. I'm going to access my fraction bar. Now on the T84, to access your fraction bar, you're going to do alpha y, and when you press alpha and y, it gives you this menu. I'm going to use number 1 for the fraction. That gives me a fraction bar throughout. And I'm going to type in the equation, which is 3x minus 1. So we have 3. When you use x, make sure to use this 3x minus 1. Then you go down, and I need to type in my domain on the denominator, which is x. Now to type in less than or equal to, we want to be able to go under the test, which is here. So I'm going to press second and then math. Second, math. And I'm going to type in less than or equal to, which is number 6. And now I'm going to press 1. Now if I press graph, that will give me my first graph. So that gives you the first part of the graph. There. Now I want the second part, so I'm going to go back into y. I'm going to go down to the second equation. And I'm going to use once again my fraction bar, alpha y, my fraction bar. I'm going to place absolute value. To type in absolute value, I have to click on math. And I need to type in my absolute value, if I can find it. There you go, under number, absolute value will be x minus 2, move to the right, minus 3. Now in the denominator, I need to place x is greater than 1. So we place x, go into the logic again, second math, greater than 1. And now I can graph it. So that's how the TI-84 graphs piecewise functions. But it's much easier. We're also going to be using Desmos because it makes it a little faster for us. And as you notice, it's not blurry. So therefore, I'm going to go on Desmos, 3x minus 1. And now to place your domain, I'm going to place my brace, x, and then I'm going to place less than, and then after I place an equal sign, it gives me the equal sign afterwards. And that gives me the first part. A little bit easier. Now y equals, I'm going to place my absolute value. You can do ABS, or I can place my bar on top of your return or your enter key. Now x minus 2, I'm going to close it. Then minus 3. My domain will be x is greater than 1. And it does it for you. So we're going to be using Desmos a little more than the graphing calculator at times. So we're going to go back and forth, just because it makes it a little faster for us to use. Example number 3. So take the time to copy down example number 3, and we'll start once you're ready, and then we'll graph it once again in your graphing calculator so you can see how we can do this type of inequality, and we'll do it in Desmos as well. But first, copy it down and create a 5x5 graph. Go ahead and pause it if you need more time. So we made a 5x5 graph, and now we have a piecewise function that has 3 components. The first one, and remember that this is your domain. Excellent. So in this case, my first part of the domain is when x is less than -3. So -3 is here. I'm going to place my dash. And the second part will be, my other breakout will be at -1. So just this part. So therefore, we're going to have my first part will be from here to here. My second piece will be here. And my last piece will be from -1 all the way beyond. Now I'm going to use my, I'm going to slightly sketch my first graph, and then I'll erase part of it. So we have -4. Then I'm going to go down 2 into the right 1, or over and I'm just going to keep this part of the graph. Now, -3 is going to be open, so therefore that will be an open circle. What type of graph is the second one? The second one will be a horizontal line at 3, so just y equals 3, which will be here, and therefore we just have to use that part of the graph. That's going to be closed, and that's going to be open. So our -3 is going to be closed, and our -1 is going to be open. In the last graph, that's a quadratic equation where your vertex is -3, 0, and then you plug in a 1. 1 squared is 1, minus 3 is -2, and you reflect it. Plug in a 2, 2 squared is 4, minus 3 gives you 1, and you reflect it. Plug in a 3, 3 squared is 9, minus 3 gives you 2, 4, 6. And I'm just going to keep this part of the graph, so therefore I'm going to use from here to here. -1 is going to be open as well. So notice by just highlighting and making your dashed lines where you have your different pieces, makes it a little bit easier. And now I just need to go to write my domain and range. So my domain, what values can I plug in or do I get back for my x? For my x, I can plug in any values. In here, there's a gap in here, but it gets covered here. So -3 is fine. But at -1, there's a gap here and a gap here. So therefore, we are going to have to take two parts. The first one will be from -infinity all the way up to -1. And it does not include -1. Then union, we continue from -1 all the way to positive infinity. Or sometimes people say all real numbers except when x is equal to -1. So that's the only gap that we have. And that's why we have to break it down. Now, if any of those two circles were closed, then you'll be all real numbers. For my range, we have starting at -3 all the way to positive infinity. So from 3, bracket, because it includes it, all the way to positive infinity. Example number 4. Copy it down, see what you get, and then we can start once you're ready. Go and pause it. So in this case, we have a 3 components, right? And actually, I'm going to go back over here because we talked about using the graphing calculator to graph this. So let me actually take the time, as blurry as it may be. So we graph this one here. I'm going to go y equals, and I still need my fraction for each one. So for the first one, I'm just going to change it to negative 2x minus 4. And the denominator will be when x is less than, so I'll go back to my test. Let's go second math. I'm going to select my less than negative 3. Make sure to use a negative and not minus. On my second graph will be just 3, so let me delete everything else. When x, now in this case we have a compound inequality that we covered before. So I'm going to have to break it down. I'm going to break out the first one when x is greater than negative 3 and when x is less than negative 1. So let's go and type in the first one. When x is greater or equal to, so I'm going to go to my math. Under my test, I'm going to select greater than or equal negative 3. Now I'm going to say an and, so I'm going to go under my test again. And on the right, you'll see the logic. I'm going to select and that'll be x is less than negative 1. So that's how you write the second one. And notice if I graph it right now, and just to confirm, your TI-84 plus is a little slow, but it does the job. And then for the next one, for the last one, I'll place alpha y to get my fraction bar. Then that'll be x squared minus 3, so it'll be x squared minus 3. And my domain will be x is greater, so I'm going to go under my test again, greater than negative 1. And I can graph it. And that should match your graph, and it does. Now, if we do it on decimals, which is a little faster, the first one is negative 2x. So you want to be able to do one or another, but you do want to get comfortable with your graphing calculator because that's what you guys will be using next year in calculus. That's for the first one, which matches 3. And we have x. And in this case, what's nice about decimals is actually you can type in negative 3 is less than or equal to x, which is less than negative 1. So you can type it in as this. And the last one, y equals x squared minus 3. And I'll place my brace when x is greater than negative 1. And close my brace. And that should match your graph. Sometimes you're able to zoom in. My scale is 2, so that should be easier to see. Example number 4. So go and copy it down, graph it on your own, then see if you can graph it on decimals, and then we can check your answers. Then at this point, go and pause it. Excellent. So you should have it already done. So we have 2, 4, 5, 2, 4, 5. So one of the things I do first is I notice that my gap is going to be at negative 2. That'll be my first part of the graph, my first piece. The second one will be at 1. That'll be my second piece. I'll continue highlighting, so therefore you should as well, just to make it a little more visual, it'll be easier for you to remember it. Therefore, that'll be this part of the graph. And to graph it, my absolute value, my vertex is at negative 3 and 0. So negative 3 and 0 is here. My slope, my line of symmetry is here. My slope for this absolute value is 1, so that my a value is 1, which is my slope, so I'll be here and over here. It also continues on this side, but I'm just going to keep this part of the graph from here all the way up to here, where this is -2. And now, open or close. This should be open, so I'll make it open circle. For the second one, we have a parabola that's facing down, where my y-intercept is 3, 0. My vertex is 0, 3. My y-intercept is 3 as well. Then I'm plugging in 1. Plugging in 1 gives you 1 squared is 1, times the negative is -1, plus 3 gives you 2, and reflected. Now plugging in 2. -2 squared is 4, times the negative is -4, plus 3 is -1, and reflected. And the only piece that I'm keeping is this part, so that's the domain is from -2 all the way to +1. And I'm going to be keeping that part of the graph. Notice that a -2 will be closed and a +1 will be open. And the last one is x. What type of graph is x? So y equals to x. That is your parent graph for a line. So that intercept is 0, slope is 1. And for that graph, we are using only the domain when x is greater than 1. So therefore, I'm just going to keep this part of the graph. And at 1 will be open as well. So therefore, we're going to have a gap in here because both of them are open. At 1 is going to be undefined because it doesn't belong to either one of them. So I just need to go to write down my domain and my range. My domain, you can say all your numbers except for 1, or otherwise we're going to say in 2 parts from -infinity to 1. In here, this gap is getting closed here. So there's no gap at -2. So it'll be from -infinity all the way up to +1. Open because it does include 1. Then the union of 1 again all the way to +infinity. Your range will be from -1 all the way up. And -1 open or close, so therefore will be a bracket, and infinity always gets parentheses. Example number 5. Go ahead and write it down, see what you get, and then we can continue. Go and pause it. So in this case, we have 3 graphs, 3 pieces of it in a function. The first one is -2, y equals to -2. The second one is an absolute value that's facing down, this part of the domain. And the last one is just x. So therefore, we can evaluate what's f of 3. Well, this is 3, and this is your domain. So I need to think, okay, 3 is my x value that I need to plug in. It's on the first part of the domain, the second part, or the third. It's on the first piece, second piece, or third piece. It's on the third piece, right? Because 3 is greater or equal to 2. So therefore, we're going to apply into this function. So we're going to plug in a 3 in here. So it just gives us 3. So that was on the third piece. How about -5? -5 is your x value. Where do I need to plug it in? That belongs into the first piece because it's less than -3. So therefore, For this function, the y value is always -2. There's no x to plug it into. How about 0? 0 will go into the second piece. So therefore, if we plug in a 0, it will be negative absolute value of 0 minus 3. What did you get? So 0 minus 3 is -3. Absolute value of -3 is +3 times a negative. We can say -3. So try the next 3. See what you get. Going positive? Excellent. So f of 2. Where does the 2 belong? The 2 belongs either the pink or the green part. Which piece? Correct. It belongs on the green. So therefore, you plug in a 2, it gives you 2. -8 belongs in the yellow piece. So therefore, if you plug in a -8, there's no x to plug in. Tells me that the y values are always -2. And -3 belongs to the neither one. There's no equal sign here, there's no equal sign here, so we say that it's undefined. And that will take us to the last example for today. Go ahead and take the time to copy it down, and then we'll start once you are ready. Go ahead and pause it. So in this case, it says the number n of monthly active Twitter users worldwide was 30 million in 2010. It grew linearly, so it's going to be a linear function, reaching 300 million in 2015. It continued to grow linearly again, so it's going to be another line, to 320 million in 2017. Write formula for the piecewise linear function n of x that models this data. Sketch a graph. We need to determine whether n is continuous function on the interval, and then interpret the rate of change in n. So a lot to work through. So first, let's go and make a graph. I know that we need to sketch it afterwards, but actually I can do it first. We're going to start with 30 million, and that'll be your y-axis, and we're going to get to 320. So therefore, for y-axis, we want to do, how big of a scale do we want to do? Do we want to do by 10 million? But we're going to have to get to 32. So let's do it by every 2 will be 100. So this will be 100. This will be 200. This will be 300. And you need to be able to write down what is the y-axis corresponds to. The y-axis corresponds to the number of monthly active users. And we have to make sure that it's in million. So number of monthly active users. Now for the y we're going to use in years, and we need to start now at 0 for the y we start at 0. For the x we need to start at 2010 and end in 2017. So we can do it by 1, 2, 3, but we're going to take a big gap. We're going to start here. This will be 2010, 11, 12, 13, 14, 15, 16, 17. And let's see. And now we can actually just graph it or sketch it. This is 2010 is 30, so this is 50, so a little lower. That'll be 30. 2015, 2011, 12, 13, 14, 15 was 300. And 2017 was 320, so it's a little lower. So therefore, those are our pieces. So we actually did the second part. Is it continuous? Yes, it is continuous. Now, if we look at some of the graphs that we covered before, not all of them are continuous. Graph number 2 is not continuous because it takes a break. Graph number 3 is not continuous because it takes a break. So none of the graphs that we covered before are continuous. This one is a continuous graph. So now we need to be able to find the equation for this line and graph the equation for this line. So let's do the first one together. Do you remember how to find an equation of a line? That's what you covered in Algebra 1 and Algebra 2. But we're going to use our point slope form. Do you remember your point slope form? Y minus y1 equals mx minus x1. But in order to use this, I need to be able to find a specific point on the graph. So we do have one point. I can use this point or I can use that point. This point is x is 2010, y is 30. This point here, x is 2015, y is 300. This point here, x is 2017, y is 320. So I have one point I can use, but I don't have my slope. So therefore, I need to be able to find my slope. My slope will be m equals y2 minus y1. Will be 300 minus 30 over 20 y2, which is 2015, minus 2010. So that gives me 270 divided by 5. And 270 divided by 5 will be 54. That should be 54. So therefore now I can use my equation. So y minus y1, which is 30. I'm just going to use my first point, equals my slope, which is 54. Then we have x minus x1, which is 210, or 2010. And now I can just solve for y. So I'm going to use my distributive property. I'm going to use a calculator because the numbers are a little large. So we have 2010 times 54 will give us minus 1085.40. 100. Move my 30 to the right because it's positive, so therefore y equals 54x, and that'll be negative 1085. So that is my first equation for my first piece. Now do the same thing for your second piece and see what you get. You just find the equation of that line. Go and pause it. Excellent. So in this case we have y minus y1 equals mx minus x1. We need to be able to find the rate of change, my slope. So my rate of change is m equals y2 minus y1, so it'll be 320 minus 300 over y2 2017 minus 2015, which is 2. So therefore we have 20 over 2, which is 10. So that's a nice number. So we have y minus y1, which is 300, equals my slope, which we found it to be 10. We have x minus x1, which is 2015. So therefore I have y minus 300 is equal to 10x minus 2015 I0 plus 300 on both sides. So y equals, let me just do this, should be 1985, 19,850. Let me confirm. So it'll be 10x minus 1985, 19,000. So that's the equation. And now we can write down our function. They want us to build our piecewise function. They want us to write down in terms of n of x. So let's write down n of x is equal to the number of users monthly of active users. Very different. We have 2. Let me just skip a space in between. So the first one will be y, well, I don't know y any longer. It's in the equation, which is 54x minus 10, 8, 5, 10. When x, if, and then place on the next line. My domain be f between 2010 and 2015. So 2010, it's x is greater or equal x, which is less than or equal to 2015. In this case, we also going to use our second one, which will be 10x minus 19,850. And that parallel domain will be if between 2015 and 2017. So 2015 is less than or equal to x, which is less than or equal to 2017. Now be careful. In this case, there's an equal sign on both. We can choose to take one out, but the only time they can have an equal sign on both if it actually matches on the same point. For purposes, we're going to go with an equal sign on both. I'll just take it out from one, since you'll go to the second function, which will give you the same number. Now interpret the rate of change in n. So we're just going to talk about the rate of change of your slope. So the rate of change between 2010 and 2015 was 54 million users. Every year, correct? It is per year. And the same thing, the rate of change, it decreased to 10 million active users, monthly users. So that is our lesson for today. Have a great day, and I'll see you guys next time.